What's up everyone? In this video, we're going to be talking about cross-sections and solids of revolution. So this is a new definition that we're working with. So a solid of revolution is the 3D shape that is created after continuously rotating a 2D shape about a line. And we're usually going to be rotating these shapes about one of its own sides. So the Regents loves to deal with these three shapes here. So we're going to be rotating a triangle, a rectangle, and a circle, and we're going to see the 3D figures that are created from that. Now, when we start with a triangle and we rotate it around, you guys can kind of see on the right side over here is what is going to happen when we rotate that triangle, right? So shifting this over to a few different angles, you can really see, hey, we're taking this triangle and we are really rotating it about one of its sides. Now, when we do that, you can see if I click this Show Solid button, that when we do that rotation, what we are actually creating is a cone. And a sketch of the shape, we start with our triangle, right? And what we're doing is we are going to be continuously rotating it about its side to create that 3D figure, okay? Now the next shape that we're going to work with is a rectangle. So for a rectangle, you can see on the right side what's going to happen as we rotate that rectangle around, right? We're kind of just rotating it about one of its sides, and it doesn't matter the side that you choose to rotate it about. The figures are always going to be the same, and that holds for a triangle too. So you can kind of see we're us rotating this figure. If we click this Show Solid button, we can see that when we do that full rotation, we are actually creating a cylinder. And again, what we notice is when we rotate the rectangle about this side, what's happening is we are kind of going around here and creating a cylinder like that. So this rectangle kind of represents half of that cylinder, and we can kind of see like this bottom side would be like the radius of our circular base. And that same kind of thing holds with our triangle as well. When we do that triangular rotation, yes, we create a cone, right? But what you want to notice is, hey, this bottom side of my triangle ends up becoming the radius of the cone. We might have to use some mathematical examples with this as well. Now the last one we have is a circle. So a circle, when we change our angle of rotation, we can kind of see what's happening here. This is the only different one because with triangles and rectangles, we rotate about sides, but with circles, we rotate about a diameter. And you can kind of see that in the animation, right? We're not like rotating about a side, we're kind of just rotating right about where our diameter here would be. And when we do that, again, you can kind of see that diameter is staying in the same spot. And if I click Show Solid, what we are creating is a sphere. Now moving on to the next definition is a cross section. So a cross section is a surface or shape that would be exposed by making a straight cut through a 3D figure. So if you take a look at this little animation here, we can kind of see every so often we are cutting this little cartoon image, and the cross section is the part of the shape that's exposed after we do the cut. And you can kind of see a more geometric example here. So here we're cutting a cube in a bunch of different ways, and you can kind of see the different shapes that are exposed when we do these cuts. Now we can make these cuts in a lot of different directions, and you guys are going to see that in these examples. So the first shape that we're going to work with is a cone. And when we do our cross sections, a lot of what is assessed is when we make these cuts parallel to the base and when we make the cuts perpendicular to the base. Now there might be some other cross sections in there, but parallel and perpendicular are some really big ones that are often assessed, and then the other ones we have to still be aware of them. So here is an image of our cone. And with this GeoGebra, what you're going to see is that this darker orange region here would be the face that's exposed after we make the cut through this plane right here. First, we're going to test it parallel to the base. So this blue plane that you see here, that blue rectangle, is like our scissors. That's our slice. That's what we're going to slice through. So if we're parallel to the base and we move that cut up or down, what we should notice is that we just have circles of a bunch of different sides that would be exposed. So When we're parallel to the base, our cross-section is a circle, and we can sketch that out. Now for perpendicular to the base, I'm going to take my plane and I'm going to perfectly make it perpendicular to my base like that. And when we rotate this around, we can see the darker shape that is exposed is a triangle. Now to look for the other ones, what you want to do is kind of like, it's hard sometimes, you have to just try to visualize this, but the GeoGebra is going to really help us out. So I'm going to not make it fully horizontal or vertical. And you can see when I do that, we get like an oval. So that's our first one. So one that we can put here is an oval. And sketch that out. Let's see if we can see any other ones that we have. Ooh, this is an interesting one. So it looks like it could be an oval, but this bottom portion here is cut off, and that's what we call an ellipse. So another one we have is an ellipse. And what that looks like is just most of an oval, but the bottom or the top is going to be cut off. So for cones, we have 4 possible options. Now the next shape we're going to do is a rectangular pyramid. So again, we're going to test when we cut it parallel to the base, perpendicular to the base, and then we're going to see if there are any other ones in there. Alright, so here's our rectangular pyramid, and the standard cross-section for this link is the cross-section where our plane is parallel to the base. So when our plane is parallel to the base, no matter what height I take this at, I can see that we have that rectangle there. And then when we are perpendicular to our base and we rotate this around, we can really nicely see that we get a triangle there. So we're going to see what happens now when we rotate our plane a little bit and make it not perfectly parallel and not perfectly perpendicular to our base. So when we do that, we can see we get, this is interesting, that looks to me like a trapezoid. First one we have is a trapezoid. And then let's see if we can manipulate this in any other way here. Oh, this one's interesting. This one, honestly, though, is probably one that's not going to be really tested. That would be like a weird looking pentagon. So we'll include it, but it's a very rare case. We have pentagon. And just pentagon just has 5 sides. This one looked really weird, though. It was like something like that. But just be aware that that can be a possibility. So I want you guys to try to start recognizing a pattern here. So when we were parallel to the base, we ended up having exactly the same cross section as what our base was, right? No matter where we cut this cone, if we're parallel, we always get a circle. And when we were parallel to our rectangular pyramid, no matter where we cut it at, we're always going to get a rectangle. So it looks so far that when we're parallel to our base, that the cross section is just going to be the same shape as the base. So we'll test that out with a few more shapes. And then when we are perpendicular to our base, what we get is a lateral face. So a cone is a little bit weird because its lateral face is like a sector. It's not really a perfect triangle, but when we're perpendicular to our base of a rectangular pyramid, all of our lateral faces are triangles. So when we're perpendicular, the cross section that we get is going to be one of those lateral faces. So this is a pattern we're going to try to see if holds throughout the rest. So next we're going to do triangular pyramid, and again we're going to do parallel to the base, perpendicular to the base, and see if there are any other ones. So here's our triangular pyramid, and as predicted, right, we know that the base of a triangular pyramid is a triangle, right? So just based off our pattern, we can predict, hey, if our cross section is parallel to the base, I can assume no matter what height I'm taking it at, that I'm always going to get a triangle. So let's just see if there are any other interesting scenarios. Let's make it maybe not fully vertical here. We can see this is interesting. We still have a triangle going. To be honest, I don't really see any other ones. So you guys can go ahead and actually know, hey, there's no other one. Now for a rectangular prism, remember the difference between a prism and a pyramid is that a prism is not coming to a point. So let's just make some predictions. So if we have a rectangular pyramid and we're parallel to the base, I'm predicting that it's going to be a rectangle. because that is the shape of my base. And then if we're perpendicular to our base, right, going straight down this way, it's going to be a lateral face. Now, all of the other lateral faces are rectangles, so I'm going to predict that. And let's go ahead and actually test that out. So here we have our parallel cross section. So no matter where I take it from, our prediction was correct that we get a rectangle. Now if we make it fully vertical and we mess around with where that cross section is at, we can see that we always get a rectangle, which is correct. Now if we mess around with this just a little bit, we can kind of see maybe this would be like a little parallelogram situation, but I think we're good to go with our rectangles here. Now our last two shapes that we're going to work with are a triangular prism and a cylinder. Now I'm just going to go ahead and make some predictions and then we'll take a look to see if it's right. So remember, with a triangular prism, this is a tricky one. The base, even though the base looks like it's a rectangle, the base is a triangle. The first word always tells you what the base is. So if we're parallel to our base, I'm going to get a triangle based on our predictions. And if I'm perpendicular to my base, I'm going to get a lateral face. Now the only lateral faces we have are rectangles here. So let's test this out. So here's our triangular prism, and when we are parallel to the base, as predicted, we get a triangle. And then when we make it perpendicular to our base, we get a really nice rectangle there. Now, let's just see if we rotate it and make it not perfectly horizontal or vertical. Oh, we can see it looks like we get another trapezoid here. So this is something we want to make sure that we add in. So we can definitely get a trapezoid. Let's see if there are any others. I think this is going to be the only one there. Oh, we get this weird looking pentagon again. So I'm going to write pentagon. And again, these aren't going to be crazy assessed, but it's good to just be aware that there can be some weird cross sections in these shapes. So our last shape is a cylinder. So let's just make some predictions. Parallel to the base, for cylinder, our bases are circles. So I'm going to predict we get a circle. And then perpendicular to our base, this is another one that's a little bit weird, but you guys just have to know that your lateral face, remember, when we open up that cylinder, we get two circles, and then we have that rectangle that rolls out, right? So this is the lateral face of our cylinder, and when we go perpendicular, we usually get a lateral face, right? So I'm going to predict that we get a rectangle here. And let's just double check that with the animation. So here's our cylinder, and as predicted, when we're parallel to the base, we get a nice circle. And notice that circle size isn't changing throughout. That's kind of cool. So when we go fully perpendicular, we can see, as predicted again, we get a nice rectangle. And then let's see if there are any other different ones here. Ooh, this is interesting. So here, if we cut at like this slanted, like fully diagonal cut, we can see we get an oval, so that's important to see. If we cut like slanted like this, we're going to end up getting an oval. And then let's see if we move this around a little bit. And we can get another ellipse as well if we like move this and cut it kind of on like an edge. So we get an oval and we get an ellipse. Cool. So the last shape we're going to do is a sphere. Now a sphere is probably the easiest one to think about because there's only one possible shape that it can be. It can only be a circle. So if we take a look at our sphere, no matter where I take my cross section, no matter where I cut, I'm getting a circle. That circle size is just changing throughout the figure, but it's still a circle. Even if I rotate horizontally or I rotate this way, no matter where I take my cut, I always get a circle. All right, so tying it all together, what should I even grasp from this? So revolutions of figures was the first portion, and no matter what side we are rotating around or what line we're rotating around, a rectangle is always going to rotate into a cylinder. And again, notice that this bottom side ends up being like the radius of our cone, of our cylinder. A triangle rotates into a cone, and again, what you should see is that this bottom side, the other side, the side we're not rotating around, ends up becoming the radius of our cone, and then a circle rotates into a sphere. Now, for our cross sections, when we cut parallel to the base, notice we always got our cross section with always the same exact figure as the base. So here are some examples that we went through today. And when we cut perpendicular to the base, the cross section is the same shape as a lateral face of the figure. Now, notice there can be more. Look out for the odd ones. Try to visualize, but in general, we really focus on these parallel and perpendicular ones.